All right, so today we're going to talk about application layer protocols. So we're going to do a quick just review of OSI models, talk about what's going on at the application layer, some basic tools, and some common protocols. So today is more so kind of, I don't want to say miscellaneous, but we're going to just touch on a bunch of different application layer protocols. We're not going to get super deep about any of them. We're going to talk about kind of like where they are, where they fit in, and just in technology in general, and just some of the things to think about when dealing with these protocols. So one, just let's just talk about the OSI model once again, right? So somebody tell me, what is the OSI model? What is its purpose? What function does it serve? William, help me out.
So it just goes over the different, well, I guess the different layers of how data goes from one endpoint to the other. So it goes through the wires, like the physical stuff, um, uh, like switches and bridges, the routers, and then it gets to the other system and then back again.
Yeah, so you need to go through each layer, but essentially what it is, it's a way that we can think about how data is encapsulated when it's being sent from one machine to another over the network, right? So like we said, we have these 7 layers. The acronym I like to use, or the mnemonic I like to use is please do not throw sausage pizza away, right? That's how I remember this. Right, so your physical layer represents the actual physical hardware. Your data link layer is where like your MAC addresses comes in. Network layer, where your IP address, right? That's where the IP layer of the TCP/IP stack comes in. The transport layer is your TCP. This is where the ports come in, and then your session presentation application, depending on the protocol you're using, they're going to fall into one of the higher level protocol that you're using, the end user protocol that you're using. They're going to fall into one of these things, and sometimes actually they'll deal with more than one, because this isn't like this is a model used to describe things, right? And so sometimes things don't fit our model exactly, but just in general, this is a good way of thinking about how things work. So at the top of there, we have the application layer. And the application layer is the one that sits closest to the end user, right? So the one that we've been talking about a lot and been using the last couple of days is HTTP, right? And HTTP is a plain text protocol, but at the end of the day, right, and I've said this a couple of times, but at the end of the day, your processor speaks ones and zeros. And so your HTTP at the top layer, at the application layer, is true just text, but as you go down deeper into your OSI model, to the layers of the OSI model, eventually it becomes just packets, and packets are just bits on the wire, right? Your application layer data is formatted and held based on the particular, so, and actually we've said this a lot, and we've used the word protocol a lot. Somebody tell me, what is a protocol? All right.
Set of instructions.
Say that again.
Set of instructions.
Close. I like to think about it as more like your protocol is, I think of it as a contract, right? Or your set of rules that we agreed to work by. So essentially, and let's just talk about the HTTP protocol, right? In the HTTP protocol, it's specified that when somebody sends a message and the verb that they use is get, whatever resource that is they're requesting, that is the get is specifying, that a server will respond to that with a status code. If the server is able to find that resource, the server will respond with a status code of 200 and send that resource over the wire in the response, right? And then there's also things about headers and then how headers are, right? So there's all these, a protocol is essentially a set of rules that determine how two machines are going to speak, what language they're going to speak, right? So where the verbs go, where the nouns go, and what do I do when I receive a specific request or a specific command? How do I respond to those? And that's what's going to be in your application layer data, right? The actual bones of the protocol itself. And so the application layer is going to be concerned with, like, this is the one that sits closest to the user, as I said. And so what we're concerned with here is the data that the user is concerned about, the actual resources that the user is trying to use. Because if you look at any HTTP requests, there's nothing about ports or IP addresses. There is something about the host, right? And there's a header for the host, but we're not concerned with MAC. All of that is dealt with at the lower levels of the OSI model, right? All of that is further down the stack. At the stack we're talking about, all we're concerned about with is the resources that are sitting on the web server and transferring those resources. And those resources, when I say resources, I'm talking about the HTML, your CSS, your JavaScript, right? Those resources that are being requested by a client and delivering those resources to the clients that request them, right? And the client's browser will then take care of how that data is presented to the end user. But that's even above the application layer. That's then talking about just the actual application itself. So, like I said, that's where in your application layer, that's where all the logic and the rules about how these these machines will communicate, that's where all of that is held, is in the application layer. So another example of application layer protocols is email. Email is one of the very first applications. The very early on in the creation of the internet, email was created as a way to send messages back and forth, right? Yeah. HTTP, headers, verbs, and request data, right? So in email, the logic and the content that you're concerned with is the actual data, the message that you're trying to send. In HTTP, we're talking about the actual resources. And then also, when we're talking about protocols, we often pair a protocol with a specific port, right? Protocols have common ports that they run on. And by default, which is where services will look for to when they're trying to communicate with a server on another machine. But those ports are just a suggestion. You can run an HTTP server on any port. And we'll see, like, there is a way to use Python to run a HTTP server, and you can run it on any port that you want. Any service can run on any port, but the default ports are there as a convention and a convenience, so that you know, on one side, I don't have to configure my DNS when I'm speaking with your server to use this port, and when I'm speaking with another server to use another port. We just all agree to just use the common port of 53. And then if there's any particular circumstances that would lead us to stray from that, we have the ability to change ports. But those ports, a service doesn't have to run on its default port. So today we're also going to get deeper into using Netcat. So you've been introduced to Netcat. We've even simulated Netcat in Python, right? When we're doing socket programming, right? So Netcat is essentially just the low-level network connection, no frills, right? It is just a raw socket connection to a service to another machine. We also have there's the NC, and then there's the NCAT version. The NCAT version is mostly compatible with the NC. The NCAT version has a couple extra bells and whistles, but I think we've already dealt with that in a CyberLab program when we had to get the NCAT version to use the -K option to keep a socket alive. So NetCat can be used with not only TCP but UDP. It's just pure network connection, pure raw socket. The same way that we were doing in Python, we were opening a connection to a socket on a just using the IP address in the port. That is what NetCat is. It is a tool that does that for you. So as you kind of just been seeing now, things have just been coming back. This is a day where some of the things that we've been going over start to come back, and we start to touch them again and go a little bit deeper. And so you see here, just like in when you're making an NC connection, all you provide is the resource that you're going to, the server that you're reaching out to, and the port that you're connecting on. And then you can perform with that raw connection, you can send, if it's a pure text connection, you can just perform the same thing that your browser does. So in the background, when you request a website, this is what your browser does. When you put in a URL, your browser then does, I mean, there's more to it than this, but just as a simplified version, your browser will send a user agent representing what kind of browser it is, the host, which is the resource that it's reaching out to, and then the get, and then the slash, which is which resource it's actually trying to communicate, it's trying to retrieve from that server. And so for a second, we're going to, let's just go through this. And you can actually, if you fire up your Kali machine, you can follow along as I do this. But just logged into my Kali machine. And so what I'm gonna do is, well, first let me see. So we use the netstat command. Is anybody familiar with netstat command? Anybody not? Okay, I see somebody shaking their head. So netstat, right? When we think about services, my Kali machine essentially has server software on it, right? There is a web server on here. There's an SSH server on here. There's an FTP server on here. Netstat tells you which ports are open on your machine. What processes have opened a port on your machine? So if I do netstat and I do dash PANT, just think pant. So the N is to not do number resolution, the T is for TCP, A is for all, and the P is for, I don't remember, so let's just do dash help, and we'll see dash P is to display the PID and the program name. So when we do netstat dash PANT, well, this is good. What did I just do?
There are 2 dashes.
Oh, I was like, what is going on? This is going to tell, this says, right, so here's my local address. I have something running on 5432, something open on 80. Well, so this is TCP. These are all TCP. This is TCP4. This is TCP version 6. This is why you have these colons. This is my local loopback. So I'm listening on 443, 5432, and 80. But for TCP, if I do it, if I get rid of the N, and then this will show me the actual applications. So HTTP, HTTPS, and 5432 is PostgreSQL. And so if I start a new service, if I go system, CTL, start SSHD, SSH. Okay, there we go. And then I do netstat pant again. Now you see, now I have 22 running, right? So the SSH service is now running. SSH is listening on port 22, and netstat is letting me know that that there's a service listening on that port. And then if I were to Control Shift T, if I were to SSH for localhost, and go back to netstat, and if I run it one more time, oh, it's not telling me. I'm connected, 22. Let's do this PANT4. Let's just look at TCP. So maybe it's because my foreign address is my same address, but if I were to SSH in from another machine, it would show me. So right here, it's foreign address. And I think because I'm just doing it on localhost, it's not showing me. 000 refers to this machine, the same way that 127, this 127 class of networks refers back to this machine. So it's not showing me, which unfortunate. But if I had a connection from an outside machine that was listening on, that was connected over 22 on SSH, I would see the IP address of that machine that's connected here as well. Actually, I think my browser will do it. So when you open a browser, it will open up several connections. And so if I go to, this is my browser, and I just go to, let's just say, google.com, and I do netstat. Yeah, so now you see all of these connections that were, like we said, when you open a browser, even though you went to one resource, in the background, there's going to be a bunch of other requests being made for JavaScript, CSS, so on and so forth, images. And here we see, so this is my local IP address, 192.168.41.40, and these are all the foreign IP addresses and which port I'm connected on. So you see some of them are on 80, some of them are on 443. So netstat can be used to show the connections on your machine, what services are listening, and if there are any outside machines that are connected to those listening services. And it goes both ways, because right now this is my web browser has made these connections to these foreign IP addresses. So that is how you see which protocols are being used on your machine at any one time. So with that, I kind of lost my place. Let me go back and see what I was wanted to show you. I lost my place for a second. Oh, yes, showing you how we can use Netcat so now I have a web server running. Let's close this browser. Don't need it. Those connections are still open for the time. Since time wait while those connections are closing, but what I'm looking for is, actually I need to open that browser back up. And localhost. Okay, so this is the default page. If you start up your web server and go to localhost or your local IP address, whatever that is, this is the page you'll get. This is the default page that comes with Apache. And just for a second, I want to just talk about we're going to talk about HTTP for a quick second. So if I cd to var www html, this is where all the resources that my web server serves live. This is the home directory for my Apache web service. And right now in here, this index.html, this is the page that we're looking at here, right? So if I do /index.html, right, it's the same page. So just by convention, if you just put in / your web server will look for, there's certain pages that it'll look up and serve automatically. Index.html, index.htm, and you can specify this in your configuration file as well if you want. But so index.html will be served up automatically. And you see here, I have this directory test, right? And if you cd to test, we see I have this page, some resource, and also this test page.html. But also notice I don't have anything called index.html in here. So now when you in your browser, and I'm doing some hand wavy here. This is not, there are other technologies that work. There are technologies that have changed the way these principles work, but in general, when you do test or anything after that initial slash is a path on that server, right? So test is a directory on my web server. We go here, you see, here's the contents of that page. So it didn't serve up any of these pages by default, and it didn't serve up a web page by default because I don't have an index.html in this directory. So right now, the way my browser is configured, it's allowing me to show the contents of a directory. This is something that we'll talk about later. This is like, you shouldn't want to do this, but just right now, this is how my server is set up. And if I wanted to actually get one of these web pages, then if I do test_page HTML, right? This is a page, this is a document that resides in this path, right? So your localhost / is going to point to that root directory of your web server, right? And by default, that's going to be var www.html, but it could be anything else. It could be, you can configure it. That's just the default convention is var www.html. Any directories in there, when I navigate to them, then becomes part of this path of my URL. And then the last part of the path is the actual document that I want to serve up as my web page, right? So with that, we get back to Netcat, and if I do nc localhost on port 80, I've now connected to my, and actually let me do this. Let's do nc-nv 127.0. So I've opened up a local connection to my web server. And as part of the HTTP protocol, I can just say get test page, right? So this is the resource that I'm requesting, and then the version of HTTP that I want to use. This is 1/0, and boom, this is just as a response. It'll give me back the, oh, actually this is saying bad request. I think that's because, let's try it again. Hold on a second. If I do git / HTTP / 1.0. All right, I gotta, let me see one thing. So here I'm doing something that's against the rules. So, and I'm getting back bad request. So let's take a look at the actual protocol for a second. Let me bring that, actually, let me just bring this back up in the same place. Let's stay here. Let's go back here and let's just look up HTTP 1 minimum requirements. For request. Server, HTTP request required headers. All right, let me HTTP 1 request. My method is required. So these are the rules for a HTTP request. Here's my method. These are the verbs that are permitted. The request URI, which is the path, and then the version. Yeah, this is what I'm giving. I think maybe, if I do NC send /r/n, I think what I'm doing wrong is that by default, yep, -c. I think that's what I need. NC-C NV 127.0.0.1 80 -C cat -C 127.80. This is going alternatives and C-C 127.0. All right, I am going to have to take a look at this again. Connected get / HTTP 1.1.0. All right, I'm gonna have to come back to this. I'm not sure what I'm doing wrong, but I don't want to get stuck on this. But essentially, if I did this, if I did /HTTP /1.1, kind of like I know I've done this a bunch of times before. I'm not sure why I'm having an issue.
Does it need to be 127.0.1.1 instead of that 0 there?
No, that's fine. That is localhost. What I'm wondering is if am I using the wrong HTTP version? And if this doesn't work, then we're just gonna have to move on. I'll have to figure it out on my own time. Still bad request. All right. But the core principle is still there. This is a raw socket. Something about my request is incorrect. And I think it's my line endings because the specification calls for /r/n and how do I send a carriage return? I'm not sending my carriage return. I think that's the problem, is that I'm not sending the carriage return. But this is still valid HTTP traffic. I sent the request that the server is saying, no, you don't have everything that was necessary, and it's responding with an error code, 400 bad requests, right? So it's saying that your request is bad. Oh, wait, let me try this. One last thing. Sorry, echo -n get / from HTTP, echo n e HTTP /1.0 /r /n /r/n. Type that to NC 127.0.0.1 over 80. And there we go. So yeah, my suspicion was correct that I'm not sending the /r/n correctly. So this is where understanding the protocol and also understanding your tool set, what you have available, comes in handy. So I don't remember the flag for sending. There's a way with NC to send, instead of sending /new line, to send carriage returns. That -c that I found up on Google wasn't working for me. But instead I used echo, and essentially I echoed this text through NC, and here is the protocol, right? My protocol version, my verb, the resource I'm getting, and then if I wanted to change this to, what was it? test_test page, test/test page.html. And there was the contents of just that test page, right? So long way around to get to just kind of saying, when we're interacting with protocols at the application layer, right? Notice I specified to NC, right? The service, I mean the IP and the port that I needed to communicate over. But once I'm in and once I'm have that connection, only thing that I'm passing over in terms of at the application layer, at the as far as what HTTP is concerned about, was this: my verb, the resource I wanted, and the version of HTTP that I was using, right? The version of HTTP that I was speaking. If I did try this same thing with HTTP 1.1, so HTTP 1.1 has further requirements. In addition to specifying just the resource I want, I need to specify the host. So if I do this with version 1.1, now I'm going to get bad request. But if I change this and after this first rn/n, I provide, oh no, actually, I think it's after here, I say host colon, and it doesn't matter what I put, blah, blah, blah. And it's /r/n. Wait, so maybe I got that wrong. So I'm confusing where my /r's and /n's go. /r/n. Anyway, the HTTP 1.1 version, the requirements change, right? So what worked in HTTP 1.0 doesn't work with HTTP 1.1 because now I'm speaking a different version of the same language, right? So at the application layer, we're not concerned with anything else that happens on any of the OSI level layers that happen below us. We're just concerned with that particular protocol that we're talking about, that we're dealing with. And so let's go back to the slides. Another tool that's, this one, you're not gonna, this is a tool that you're gonna use often. This is what Telnet stands for, teletype network. And what it was was the way that you got a remote desktop back in this was like one of the first remote desktop applications. You would telnet to a server, and then you would get the server would give you a shell. Sir, it's out of favor because as a remote desktop application, because it uses plain text. So anybody sitting in between you and the server that you're communicating with or on that same network, they can see all the commands that you're sending over the network, including any passwords that you're sending, like the password that you're using to connect even. So this has kind of been pretty much supplanted by SSH, or not pretty much, has been supplanted by SSH. You're not going to use Telnet, but what Telnet does come in handy with is you can use Telnet to connect to a server on any port, just kind of the same way that you use NC to provide a server and a port. And it's just a kind of rudimentary way to see if that port is actually open and listening. So sometimes, especially like on a Windows system where you don't have NC installed by default, you will have Telnet installed by default many times, and you can use Telnet as kind of like a poor man's NC to just kind of see if a port is open. Uses the default port of 23. It's generally going to be always there, even though, as like I said, in terms of using it for a remote desktop system, it's not going to be used very often, if at all, but it is still installed on most systems. And here you can see doing the same thing with port 80, but over Telnet. Some common protocols that you're going to come across, FTP. FTP, so the same way that your HTTP server has a root directory. So what one FTP is file transfer protocol, and it's exactly that. It is a protocol used to transfer files between two machines. So like nowadays, when you're doing any kind of file transfer service, or any kind of file transfer, you're most likely going to be using either some kind of shared application like Google Drive or OneDrive or Box, something like that. Or you'll just host it on a web server and tell somebody, hey, go to my web server, download it from this link, right? But before that, and before torrents and everything, this was like not only how businesses shared things, but this is also how like users on the internet, this was their way of peer-to-peer networking, right? So people would set up FTP servers on location servers that they had available on the internet. Sometimes their own server, sometimes their employer's server, right? And this is how people did file sharing back in the day. And then one of the ways that they did that is like FTP requires a login, right? So it requires a username and password. So, but instead of, if I'm just making this available to the world, I'm trying to get everybody to listen to my music or whatever, or what have you, look at these funny pictures, the first memes that I'm sharing with everyone. I don't want to set up, everybody have to set up a username and password because I'm hosting this on my server. I didn't need to maintain that database of users. And then these users, right? So what they came up with was a system where you could log in anonymously. And what you would do, you would still get prompted with a login, but then as a username, you would provide anonymous, right? The word anonymous, that's your username. And then the convention was to provide your email as the password, but really you could type in any junk. It wasn't checking the password against anything. And then you get access to my server. And then you would use a series of commands like get or put or whatever. You would essentially be on my server inside of that root directory. And you'd have access to CD into different directories. So I might have a music directory, a video directory, text directory, pictures, and you would CD into whatever directory like you would just like if you had a remote shell. And then you would say get to get whatever files that you want. And depending on the type of file, and so you'll get into FTP, but you'll see there's depending on the type of file, you would specify commands to specify whether you're getting a text file or you're retrieving a binary file, right? And so that's just a little history on FTP. SMTP, Simple Mail Transfer Protocol, is one of the ways that emails move around, and then SSH, port 22. This is how you're going to do remote desktops on Linux systems. This is the default. This is the gold standard. And just like how when we were talking about encryption, and we're talking about public and private keys, and how when you start a HTTPS server an HTTPS conversation, there's that exchange of those keys, and then we get those private and public keys to exchange a symmetric key. SSH works the same way. SSH works with a public and a private key. You put your public key on a remote server, and then that'll allow you to log in without a password if the server is configured as such. HTTP, port 80, and Git, which is what our repos use, and what today at lunch, Chris is going to be giving a deeper dive into Git. So I think you should definitely try to attend that if you weren't planning on it. Try to attend that because some of the problems in CyberLab today have to deal with Git. You might want to hold off on doing those until after Chris has had his presentation to get a better understanding of how Git works. So FTP, file transfer, it's unencrypted. Like many early protocols, encryption just wasn't a thought, just security wasn't a thought back in the wild west of the internet. So a lot of protocols are just plain text. Works on port 21, but it actually works on 2 ports. So 21 is the port where your plain text commands that you're using to maneuver and navigate around in the FTP directory go over 21. But when you're sending data, that's actually going to go over port 20. And like I said, when you come across an FTP server, you might want to check and see if you can log in anonymously There's still servers out there that have anonymous login permitted. And then look for default logins. This is something that we're going to talk about more when we get to PWK. But just know, like, when you install an application, usually that application, if it has some kind of admin interface, that admin interface or even that default login, there usually ships with one default user, right? And that default user was going to have a default password. And a lot of times people just keep running with it. Like, I'm sure many of you in your home, you have a wireless router, and I bet many of you have never changed the password for that web interface on your wireless router. And so if anybody gets access, they can get access to that admin panel on your wireless router just using those default logins. Right? You can just Google up and find out what the default login is for many applications. And this link will give you some of the FTP commands that are the commands that you can use in an FTP session. SMTP, simple mail, works over port 25. When you're trying to crack an SMTP server, there is a command vrfy which you can use to verify which accounts exist. And then once you get an account, then you can go about once you get a valid username, you can go about trying to get a valid password. So you can also, once you get an account, you can then look at email, and then there's often useful data inside of emails, right? So just when we start thinking about cracking applications, don't just think about cracking the application itself, but also think about gathering data and where there might be useful information. And that's a link. We'll put this repo will be up in, these slides will be up in your repo. You can check those links out. Or actually, I'll put these links in Slack. So if you want to, you can check out these links to get more information about these particular protocols. And then here's the one, SSH. And then this is a hugely important protocol because, like I said, this is the gold standard for remote desktops in the Linux world. Stands for Secure Shell. It's going to be running on port 22 most often. That's the default, but can be changed. And what it does is it sets up a tunnel between two machines and encrypts all the traffic in between them. Encrypts all your the commands that you're sending and the responses, the data that you're getting back from that shell. So all that information that's displayed on the terminal is being transferred back and forth between the two machines over an encrypted tunnel. And you can look for what when you take a look today, you're going to take a look into how SSH is configured and where the keys are stored. And when you get access to a machine, this is something that you're going to be looking for, is looking at when you get access to a user, see what machines they have, what SSH keys they have stored on their machine, and then then that's an easy way to pivot to that next machine, right? If you compromise my account and my account is set up with passwordless login to another server, you now have access to that server because you have compromised my account. And so this is just a graphic of how your traffic is encrypted. All the data is encrypted. A tunnel is created between your server and between your PC and the server that you're connecting to, and all of the communications that between the two machines then go through that tunnel. Also, as part of the SSH suite, they have file transfer applications. So there is an SCP, which is just secure copy, like the CP on your machine, but this is going to copy machines between your machine and the remote machine. And there's also SFTP, which is secure FTP, which is a version of FTP that's also encrypted. So as part of SSH, there's a number of tools that are part of the SSH suite of applications, and you want to take a look at all of them. So if you just go to your terminal and type SSH dash and type tab, you'll see like half a dozen commands come up, and you want to just be aware of what they do. Some of them are useful. Some of them you won't use too often, but some of them are indeed useful. And take the time to go ahead and set up password lists. Generate your own SSH keys so that you can set up password list authentication for any service that you come across. And then the last protocol that we're going to talk about is Git. So what is Git? Git is a version control system is what it is. What Git's purpose is for you to store different versions of a document through different points in time, to store the different snapshots of a document through different points in time. Mostly this is used for code, right? But this can be used for any kind of text document. So if you've ever worked on something and you need to keep different versions and you just kept different versions by making a copy of the file and giving it a different name, right? After updates, final version, really final version 2 and 3 and 4. This is what Git does. This is what, when you do those commits, you're giving that snapshot of that code or that text, you're giving it a name to specify what the updates that you've made to that document have. So those names that you give it are what we call commits, and Git keeps a history of the life cycle of that document. So using Git, you can go back and see how that document has evolved. You can kind of rewind through time and see past versions of that document. Set up your SSH keys and use them with GitHub, so that way you don't have to log in every time you want to update your repo. You won't have to provide any username or password. And you don't need to go through the Git guide, I'm going to say, because there's only a handful of commands that you really need to know. Chris is going to go over that. Basically, he's going to go over in depth, but basically what you just need to know is Git clone, which is to copy somebody's repo. Git add, once you've made changes to a file, to add that file to what's called the staging area. Git commit, to make your save, to name the saved version, and then Git push, to push your version up to the repo. So with Git, what you'll see is you have these different versions of the files, and then over time, each of these deltas are just a way to represent the different changes that have happened over time to these files. And Git allows you to then rewind to any of these points in times to get those versions of the file that existed at those points in time. Okay, so with that, we're going to wrap this up, and then we're going to I'll open up the workshops and let you get into CyberLab. I'm going to be working in CyberLab today, and you're going to be working with these protocols and some other miscellaneous commands on your Kali machines. I want to say just leave there are 2 Git problems. I want to say leave those Git problems until after lunch, so after you've attended Chris's info session to kind of get some more information on Git, because I know Git, there's a ton of commands. We really only need you to know a handful of them. It's something that's going to be used a lot in technology, but as you're not going to be software developers, it's not going to be something that you need to get intimately familiar with, but you should know the basics. So application layer, this is where everything that the user is concerned with, this is where that happens. Tons and tons of application layer protocols. We've just talked about a few, but also as we've talked about these common protocols, we want you to just, as we're getting closer and closer to the red team, to start thinking about the different ways that you can kind of abuse these protocols, right? Do things that weren't meant to be done to gain access. We want you to start getting into that hacker mindset. And then just know that a lot of these early protocols, because when the internet was first set up, was kind of just the wild, wild west, and people were just doing what worked at the time, just getting something to work and pushing out the door. A lot of times, a lot of these things weren't designed with security in mind. So a lot of these older protocols weren't designed with encryption. And so if you can get a capture of them, you can see what's going on in plain text. So with that, just take a break until 11 o'clock as I open the workshop and set up the pairs for today. Once the pairs are set up, I'll open up the breakout rooms, and then you can get started on today's workshop.